Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, we have discussed about concept of probability distribution function or cumulative distribution function. So now here in this video, we are going to discuss about properties of cumulative distribution function. So mathematically, the probability distribution function is given by or defined as fx of x is equal to fx of x is equal to probability of x less than or equal to x. Fx of x or simply f of x is equal to probability of x less than or equal to x. So this is the mathematical expression of the probability distribution function. In this expression, this capital X is the random variable and this small x is the value of the random variable. So if fx of x is the probability distribution function of a random variable capital X, there are some important properties of the probability distribution function or cumulative distribution function. So that are, first one is fx of minus infinity is equal to 0. So we know that the probability of an event is a non-negative real number in the range 0 and 1. The probability for an impossible event is always 0. We know that impossible event never occur, that is x is equal to minus infinity. X is equal to minus infinity is the negative integer. So we know that the probability of an event is a non-negative real number is in the range 0 and 1. So therefore, according to definition of cumulative distribution function, substitute small x is equal to minus infinity. Fx of minus infinity or f of minus infinity is equal probability of x less than or equal to minus infinity. So that is probability of minus infinity. So the probability of x is equal to minus infinity value is 0. So that is the first property of the CDF and its proof. And second property, fx of plus infinity is equal to 1. Here fx of plus infinity represents the the summation of all probabilities up to x is equal to plus infinity. So that is the sum of all the probabilities of random variable x in a given sample space, which is always equal to 1. So that is fx of plus infinity is equal sigma x is equal minus infinity to infinity probability of x. Sum of all the probability values is equal to 1. Sum of all the probability values of the random variable is 0. So therefore sigma x is equal minus infinity to infinity p of x value is equal to 1. And this is the second property. And third property is the value of the probability distribution function or the cumulative distribution function lies between 1 and 0 and 1. That is 0 less than or equal fx of x less than or equal to 1. Now coming to the proof. Since the distribution function takes the values of all the probabilities, the range of the distribution function is also the same as the range of probability. So that is the probability distribution function lies in the between 0 and 1. Next, fourth property, the probability distribution function or the cumulative distribution function fx of x is a non-decreasing function. So that is if x1 less than x2, fx of x1 less than or equal to fx of x2. So now coming to the proof, fx of x is a non-decreasing function of x. Since the distribution function is the sum of all non-negative probabilities of the event x less than or equal to x. If x increases, then the probability distribution function also increases. That is, the distribution function is a monotonically increasing function between 0 and 1. This is the proof of the distribution function is a non-decreasing function of x. Next, fifth property, probability of x1 less than x less than or equal to x2 is equal fx of x2 minus fx of x1. Now coming to the proof, it is known that the events x less than or equal to x1 and x1 less than x less than or equal to x2 are mutually exclusive events. So the probability of the event, that is probability of x less than or equal to x2 is equal probability of x less than or equal to x1 union probability of x1 less than x less than or equal to x2. So union means summation. The probability of the event x less than or equal to x1 and x1 to x2 are mutually exclusive event. So that is the RHS term of the above equation is also written as probability of x less than or equal to x1 plus probability of x1 less than x less than or equal to x2. So from this equation, RHS side of the first term is going to the LHS side. We have probability of x1 less than x less than or equal to x2 is equal probability of x less than or equal to x2 minus probability of x less than or equal to x1. So from the definition of the cumulative distribution function, and what is the definition of the cumulative distribution function? Fx of x is equal to probability of x less than or equal to x. So this is the mathematical expression of the cumulative distribution function. So using this definition, fx of x less than or equal to x2 is fx of x2. Probability of x less than or equal to x1 is fx of x1. Also, if the value of the random variable small x2 is infinite, and x1 is equal to x, then from the above equation, probability of x1 is equal to x and x2 is infinity. So that is probability of x greater than x. So probability of x greater than x is equal fx of x2. x2 is equal to infinity, x1 is equal to x. From the second property of the cumulative distribution function, fx of plus infinity value is 1. So probability of x greater than x is equal to 1 minus fx of x. And this is another property of the, and this is one more property of the cumulative distribution function. Next property, fx of x plus is equal to fx of x. So this property, the proof of this property, it states that the probability distribution function is continuous from x to x plus, where x plus is an infinitesimal increment in x. And next property, probability of x is equal to x is 0. So we know that using fifth property of the cumulative distribution function, probability of x1 less than x less than or equal to x2 is equal fx of x2 minus fx of x1. So using this property, if we substitute x1 is equal to x minus epsilon and x2 is equal to x, we get probability of x1 is equal to x minus epsilon, x2 is equal to x. X minus epsilon less than x less than or equal to x is equal to fx of x minus fx of x minus epsilon. In this equation, substitute epsilon is equal to 0, we get probability of x is equal to 0. So these are the some important properties of the cumulative distribution function of the random variable. So this is very important question. The properties of the probability distribution function and cumulative distribution function.